Sorry. Testing, testing. Can you hear me online? Can you hear me? Can you hear me? Hello everyone. Can you hear me? What about now? Can you hear me now? Okay, perfect. Thank you. Week 5. Okay, great. Hello everyone. Hey, hello. Great to see you again. I feel like I haven't seen you for quite a long time. So I will give the lecture for today. So before we start the lecture, so again, let's have a look at what we have learned and we are going to learn. So till now so you may have noticed that the first half of this course is quite like content heavy. Like you learned a lot of stuff so far. So you learn about JavaScript, you learn TypeScript, you learn about how to use Git. We also learned pipeline and also a lot of testing. But from this week, like from this lecture, we are going to have less complicated new stuff. So still very important, very interesting contents about software engineering fundamentals, but you feel like you get a little break. So a lot of things that we are going to talk from this lecture on, like will be building on top of what we have learned in the first 4 weeks, and it will kind of get a relief. And you are going to practice what you have learned so far in the project iterations, but you feel that the project is getting a little bit harder, like comparing with iteration 0 and 1, but there will be less new content. So this is how and why this course is designed. Like we need to give you the basic stuff that you need to get those content learned so that you can start building your project. Okay, so today we will talk about persistence. And we'll leave iteration to next lecture, so Wednesday lecture. So the reason is that we hope that you can come with your, have a meeting with your team, read the iteration 2 spec, have an overall understanding of what iteration 2 is about, and then we are going to have a lecture talking about iteration 2, so that you may have some questions prepared before coming to the lecture, instead of like we released the spec yesterday and then we talk about iteration 2 today, so that you can get some preparation before we're talking about iteration 2 in the lecture. So today, other than persistence, we will talk about exceptions, and hopefully we can also do some like designing for maintainability, so that the Wednesday lecture will be like 2 hours focusing on iteration 2. So get you prepared for the iteration 2. So that's the basic idea and what we are going to talk about this week. So first of all, the first lecture today is about persistence. So anyone knows or can like want to have a guess like what is persistence in a software project or in a software product? Like any guess? Yeah. Store something for a long time. That's perfect. How did you know that? Guys, yeah, that's absolutely correct. So storing something for longer time. So why we introduce persistence in this course? So thinking about your iteration 1, that you've been working on some functions or features like that can help your users register for an account, right? But we are not storing this data anywhere. So that when a user comes to our platform, comes to our hat, and they register onto hat, and then when they come back again the other day or next time, they need to register again, right? Because we are not storing this kind of data, there are like credential data anywhere. So we need a way to store our data for longer time. Right. So this is relevant to data. So this is some like recap of what you learn in high school or other courses. So data can be some like anything. So for example, this text on the slide is a kind of data, right? Or you may play with spreadsheet before or Excel before, right? So those kind of information on the Excel or spreadsheet, they are all data. But from data, like when we have a bunch of data, we can extract some insights from this data. So for example, the recommendation system, right? So they are insights coming from a lot of data. But this is not what we are going to focus on in this course, like big data or data analyzing. So that will be like some other courses like 3311 or others. But we, in this course, we will talk about like very basic, like the most essential but not quite complex type of data like we need to store for our software product. So the examples, like other than for register and login again, so this kind of example. So other example may be, so have you ever used a subscription on YouTube? Yeah. So this is also a kind of data that we need to store in our software, right? So you subscribe to this channel, and next time when you open your YouTube, there will be some recommendations, some new videos from this channel and others. So these are also data that we need to store in our software products. And others like, for example, when you use Instagram, like you may notice that different people use Instagram, like they got different recommendations, right? So these are all because they store some of your history data and they know what your interests are. So these are data in your software. So one part of this course, we talk about like full stack, like we are designing full stack software. And one critical part of a full stack software is this data layer. Can you see clearly from the back? Yeah? Okay, all good. Yeah, so this is the data layer. So data layer is where we store this kind of data, like the examples that we gave. And there are also other layers that use the information of the data from our data layer. For example, the interface layer. So what is an interface layer? Like, where's the button? What color is that button? What kind of text is showing on that button? Or like whatever you can see, right? So those are like the interface layer. For example, this click on my slide, those are like something on the interface layer. And the business layer is like, for example, I click on this button, it will lead me to the next page. And when I click on the other button, it will lead me to another slide. So this is what's happening in the business logic layer. It's like an interface layer and business logic layer, they are both related to the front end. Like you do something, like interact with any software, interact with any platform, and they show you something different. So those two layers are relevant to the front end. Well, the service layer and the data layer are what is in the back end. So the service layer is actually what you have done in iteration 1. So some functions. Right? So those are the service, what is doing in the service. So maybe have some algorithms, maybe have some functions, and those are in the service layer. And data layer is what is stored, what kind of data is stored, like how they are stored. And those two layers are in the back end. And for this course, we are mainly building the back end. And we gave you a front end, like already coded front end, and you will learn how to make the front end make your back end work with the front end so that you can have a full stack software at the end of this course. Right. So we have learned a lot in the service layer, like how, like the functions that we wrote, and now we are going a little bit further to the data layer from this lecture. And also you can see from this column, other than the data layer, all of the three other layers are stateless. What is state? Like what is your understanding of state? What is the state of a software? The state of software, for example, is, you can think of like the current status of your software. So this is the state of my current slide, all right? And and they are stateless. So I'm not sure whether you remember, like when you have a very low internet connection, and when you refresh your Instagram or YouTube, there will be some columns showing on the app with no contents in that, right? So those are stateless. And what is shown actually in those boxes actually getting from the data layer. And the data layer has the kind of data. Yeah. And those are the state of your software. And how can we store data in this data layer? Or data layer, we often call it database. So it's a more commonly heard term, is called database. So what is in the data layer is the database. And there's a lot of different types of database. And the three main ways to store data, like the first one is in memory. In memory data is like, so in memory data, is the data, for example, variables. Like when you call a function, there are some variables in that, right? So those kind of data that for those variables are stayed in memory only. Like when you restart your app or when you call that function again, those kind of information is doesn't exist any longer, right? So those kind of data is stored in memory only, and that is not persistent, meaning that when you restart the app, when you get a power cut, those kind of data is lost, right? So that is in memory. But in memory, data can sometimes be also be helpful, like also use in some cases, like other than the variables in our functions, but also in like stock market. Like when the data is changing very fast, like in the stock market data, so in that case, they store that data in memory because it can be refreshed very quickly and reflect the change very quickly. So this is the benefit of storing data in memory. And also in some games, like some video games that you play, you may have a leaderboard, right? So that kind of leaderboard data is also used in memory storage because they can refresh very quickly. The other way of storing data is storing data in a file. So maybe you have used OneDrive, used some other like cloud file system. So those are actually file-based database, but they are not used for software product. But you are storing your data in a file, maybe an Excel, maybe a Word document, maybe a Google Doc, right? So this is in file database. And this is actually what we are going to introduce in this course, like how we can store our data for our software projects in a file. And this is very easy to do. It's not very complex, but it also has some like both pros and cons. The pros is that you can have some logic around, not logic, some layers for your file. So for example, you may have one file in this folder, another group of files in another folder. And you may have another like top level folder like contains both of the folders, right? So you can have this kind of layers for your data. And you can also set this, different kind of security of privacy constraints to the different folder. For example, this folder's files or data is more private. We need to have like stronger privacy security protection for that folder, but the other folder is okay. But you can also share the data the data in different folders with different people or different software products. So this is the pros of in-file database. But the con is that you cannot have complex relationship between the data because you are just storing the data in like a string format or something. So you cannot have a like very complex relationship between different kind of data. For example, this user's password is matching with the username. So this kind of data is enough for in-file database. But if you have more complex in a large software system, so they may have very complex relationship to each other. So in-file database may not be enough. In that cases, you may need some SQL databases that you will learn in the 3311 course. Yeah, and we will not cover that in this course, like this is software engineering fundamentals course. So as you move down this list, the barrier to entry becomes higher, it becomes more and more complex, but the performance is also getting better and better. Yeah, sorry, because online students are asking us to be quiet in the audience because they cannot hear. What about now? Ask them what about now? Okay. Yeah. Cool. Yeah, so this is like what persistence means. So persistence means that we want to store this data longer in our database. So persistence basically means that when program stage outlives the process, maybe you have a power cut, maybe you restart your system, the data can still be there. Like for example, the user's registration data. And persistence for software products can be interpret it very broadly, but in this course, we'll just define it to store data to our disk. Okay, so now is the question, like more relevant to our projects or any software projects. So how can we modify our project server to persistently store data? So for example, user registration data. So how can we store this data? Yeah.
Use the JSON file?
In a JSON file. Yes, that's correct. So when we introduced the JSON file a couple of weeks ago, we mentioned that JSON file is the data interchange type, right? So interchange data type. And it's very powerful, like when we want to store some data from our program in that file so that it can be retrieved for other purposes in the future, right? So this is how we can store data in a file. So we can change it to a JSON file, like a JSON string, and store this JSON string in a JSON file, and later we can read from that JSON file. Okay, so let's have a look at what we have learned in the previous lecture when we talk about JSON. Okay, so this was the example that we used in the Week 3 lecture, like when we introduced the JSON file. So we mentioned that when we want to read or write with a JSON file, we need a library called FS. So this is the library is the one that we use to read and write with JSON file. And then we may have a data, maybe an object like JavaScript object, maybe an array. So here maybe the user data or the what was that, like user store or data store, right, in iteration 1, right? So this is maybe your data store, and you may have some data in that, and then we JSON stringify this data store object, and this data will become a JSON string. So this is recap, like what we have learned before. And then we can use fs.writeFileSync and write this data to export.json, but it can be different. It's just the file name, the JSON file name that you want to write this data to. So maybe for this case, maybe the data store, was that data store? .json, right? So in this way, you can write your data into a JSON file, and it will be stored in the file, like in your folder, in your project. You can, and then you can use maybe like git add push to push your the data, the JSON file into your GitLab repository, and it will be there forever before you change or delete that. Right. So very simple. So as you can see that from this lecture, the contents will become much like more and more easier. So this is basically how we can store that data in JSON file, and also we can use the same way to read this data. So when you have new user registered for your Kahoot, you write their registration information in this data store.json file, and then you can also read that file when a user want to log in, right? So when a user want to log into your Kahoot or Kahoot, and then you can compare their login information with what is stored in this data store.json file. Right, so basically you can just use like fs.readFileSync, and then JSON pass this JSON into a data. So data is the JavaScript object. So you can use the information from this data object. That's it. So very simple. Right. So in your project, you may want to do something more. So in iteration 1, you had the data store, the object, and you also had a function called admin org register, right? So when a new user register in your Kahoot, you push a new user's information to this data store. And now you may want to have a function maybe called save. Oh, sorry. this is a save function, and maybe we can define this save function. I'm not going to write a functional script, but just show you the overall flow, like how you can save the data in a JSON file and then how you can read that. So how can we save it? Just here, you can just copy here, put it here. So this is how we save the data, right? So it's not data structure, it should be data store. Right, so this is like whenever a new user registers, to call this save function, and what's in this save function is just save this data store in your file, right? And then what else should we do? Is this it? Yeah, I think this is it. Like when we want to write to this file. However, you may also want to read from this file, right? Like when a user wants to log in and you want to read from this file, so you can just use, yeah. So can comment here. So you read from this JSON data store.json file, and then you JSON parse that into data store, and then you can use this data store later. Right. But before you do that, maybe for the first time you store your data store in this JSON file, there's no this data store.json file yet. So you may want to add some more logic to check whether this file exists already, right? So if the file doesn't exist already, you need to just write to this file, that'll be fine. And if the file exists already, you need to read from this file first, and then when calling the admin aux register, like when some change to this data store, you just update that, and then write to data store.json file again. All right. Yeah, I think it's, yeah, question.
So just for the persistence layer, we need to have one file for it, right?
The question was, if we want to have a persistence layer, we need to add this one file, right?
Yeah.
Yeah, so yes. So for this single purpose, like we want to store the user's registration information, then you only need one file to store the user's registration information. But if you want to store other things, you may want to have another file.
So would that be recommended for iteration 2?
Iteration 2, yes. So iteration 2 will require you to add a persistence layer to store this data store information. Oh, sorry, I'm having a very bad headache. So sometimes you may see me in a very ugly face. It's because I'm having a headache. Sorry about that. It's not because I'm not happy with you, just my headache. Oh, good. Any other question? Yeah, all good? Yeah, you can see it's not very hard. It's quite straightforward. Let me check if any question online. Yeah, all good. Let's go back to our slides. Yeah, so project iteration 2, we'll be adding a persistence layer, but it's not hard. It's pretty easy and quite straightforward. And you won't be asked to add a very complex database like SQL database. Just file-based database will be more than enough for this course. And you can also experience having a data layer in a software project without introducing too much complexity. Yeah, oh, sorry. So this is basically the process, like because we have learned HTTP server now. So the process is that when the server starts, we open this JSON file and set the global variable to be passed to the... Oh, thank you so much. Thank you. I really appreciate that. Sorry. Thank you. This is so helpful. I didn't sleep well for the past couple of nights, and this morning when I wake up, it's just very bad headache. Thank you. Oh, thank you. And then we will have a timer in the project. So maybe based on timer, like after a couple seconds, and then or at the end of every root call, like you save this kind of data in your JSON file. And the way that we store is just store it in a file. So this is the process. It's not too much conflict. That's it. Yay. So till now, you have got everything you need for iteration 2. Yeah, so everything that, yeah, question.
That will release on Wednesday, right?
Sorry?
Iteration 2 is not going to be released on Wednesday, right?
Sorry, can I?
Iteration 2, the information, the video will release on Wednesday.
Oh, yes, the video has already been released in the spec, but it was a recording from a previous term. Next lecture on Wednesday, Hayden will join us on Wednesday, and we welcome any question about iteration 2, so we'll have some like in-person discussion or live discussion about iteration 2, rather than you just watch the recording. Because iteration 2 is getting a little bit harder than iteration 1 and 0, so we think maybe giving you a recording may not be enough. So we are going to have a lecture talking about iteration 2 on Wednesday. Yeah, but you can have a look at that recording first, like before coming to the Wednesday lecture if you have time. But you can just read the spec and have an overall understanding of what is in the iteration 2 before the Wednesday lecture. And it will be great if you can also have a meeting with your team and come up with some questions. You can bring your questions to the next lecture. Yeah. So yeah. So now the next lecture and the next lecture, they will be relevant for iteration 3. But again, like we want you to learn these contents early in the lectures and then practice them in the lab next week before iteration 3, so you can get prepared for iteration 3. Okay, so it's exceptions. We talk about exceptions today. You practice in the next week's lab and then iteration 3 in the project. So exceptions. So exceptions is also about correctness, like make sure your software products has less bugs, not less, but protect your software product to like make sure it's safe. Right? We talk about like using jest test. We talk about tag scripts. So both of them are introduced to make your software product safe. And so as this lecture, so exceptions is also about making your software safe. So it is about dealing with errors and making your program more robust. Okay, let's have a look at this example. So let's have a quick look at this example. So we use prompt function. So you have used the prompt function in a lab before, so you know how it works, right? So it reads from a user input from the terminal, right? So this is prompt function, and it's from the prompt sync library. And the function that we have here is to calculate the square root of x, which is a number data type, right? And return max.power is the function to calculate the square root of number. And then after we define this function, we get a user input, like what kind of data that they want to, what is the number that they want to get a square root of. So we have prompt function, please enter a number, and then we console log the square root of this input. Okay, so this is the flow of this function. Let's try to run this function and have a look and see if there's any problem with it. Sorry, I'll make it a little bit bigger, and then clear. Okay, so I'm going to call this function npm run ts node. This file's name is called justcrash.ts. And then please enter a number. Can anyone give me a number that you want to get a square root of?
81.
Sorry? 1?
81.
A1?
Yes.
Nah, nothing. because it's not a valid number, right? So this is expected, right? Any other number that you want to try?
-1.
-1. Okay, good on you. Oh, sorry. It should be -1. Yeah, no. Right, because they are not valid inputs. So how can we handle this kind of unexpected user input? Is there a way to handle it? Any suggestion? Like how can we handle this kind of invalid user input? Let's have a look at this negative example first. So maybe we can have something like if. Okay, so maybe before we call this function like max power, we can check whether this x is negative or positive, right? So we can check that. So this is if x is negative, and then what we can do, maybe we can just console.error and then give an error message. Input is negative, and then we process.exit. We quit the process, right? So this is one way like we can handle this potential invalid user input. So let's try again and put in -1 without giving us a null. It shows us like input is negative, right? So this is one way of handling invalid user input, and there's no issue with that. It's absolutely okay. And then you can have another if statement. So if the input is not a number, like for example the A1 example, right? However, there's one other way that we can handle this kind of invalid user input. We can, instead of having console.error input is negative and then process exit 1, we can just throw an error. So the way we handle it is say like throw new error and give it an error message saying that error input, which is negative. Okay, so let's have a try running this code. Oh, sorry, the wrong one. That is throw catch, I believe. Yeah. No. Which one? Exception 1. Okay, that is exception 1. So exception 1 is the same with our example, but there's something new here called throw new error. And let's see how it looks like. Exception 1, exception 1, and then let's give it a -1 again. And you can see this is what is throwing to us. It's error message. Looks very similar to the error message when we have an undefined variable, or like it looks like the error message or the error message that JavaScript throw to us or Node.js throw to us, right? And yeah, and this is the error message basically, and some more detail like where the error happens at square, and more high level like explanation, and then blah blah blah. So this is how throw new error works. But what is it? Like why do we need this kind of throw new error, right? So this is exception. So when we throw new error, we are actually throw something called exception. So exception is an action that disrupts the normal flow of a program. So it disrupts there and exits the program there. You do not need to have like process.exit1. And this action is often representative of an error being thrown. And it's a way of recovering from errors. Okay. And it's a method of protecting our software to be safe, And different language have different ways of protecting our software to be safe. So for example, in C, when we write like if x is negative and then we do blah, 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 right? So this is the way like we are familiar with, like how we handle errors in C. But in JavaScript, it relies more on exceptions to handle errors. So this is two conventions. Like we cannot say which way is right or which way is wrong. Like both are correct. But there are different conventions of handling errors for different programming language. Like the if statement and then the console log error and then process exit. So that way is the convention for languages like C. But for JavaScript, the convention is using exceptions. And they also have different mindsets of dealing with errors. So in JavaScript, like throwing errors is, like we call it, easier to ask forgiveness than permission. So this sentence is not created by me. So this is the mindset of JavaScript. So it's called easier to ask for forgiveness than permission. So the idea is that it encourages you to assume that everything works. Just run the program. However, if there's something wrong happened, and then deal with the errors. Otherwise, it just assume everything to be working fine, and then try everything, and then catch the error. So this is the convention of JavaScript. The good thing about this one is it first assumes everything works, so the core logic is there. It's not disrupted by our catching errors here and there. So the core logic is there, like together. So it's less disruptive, and the core logic is simpler. But they also have some cons that we'll show later. The other like convention for programming language like C is called look before you leap. So check first, make sure everything works, find any potential issues first, and then run the program. So it's like different mindsets, like in the different programming language. Like JavaScript is assume everything works, and if anything goes wrong, catch it and deal with it. But C is like check everything first, make sure everything works, and then run the core logic. Right, so this is the convention of different programming languages. Okay, so let's come back to this example. We had throw new error, so we throw that, but we didn't handle it. So we haven't handled this error yet. So how can we handle it? So the syntax for JavaScript exception is called try and catch. So this is how it looks. So building on top of this, we try the core logic first. The core logic that we want to have is this: get a user input and then console log the square root of this input number. So this is the core logic. We just try it, and then if there's anything wrong, we catch it. We catch this error, and then we handle it in this catch. And how we handle it? We may console.log some error message, like error.message. Okay, you may come up with another question, but I will answer you soon. So this is the core logic of using try and catch, which is exception in JavaScript. So above try, so these are just defining functions, importing libraries, and global variables. But the core logic is here. We try it without interrupting it. But if there's any error, we console log this error and stop the program. Okay, so if you have other things under this console log square root, for example, we make console log A and then B or whatever you have. So if they catch an error somewhere during the core logic, they will stop the program. So for example, the error may be caught here, like when they run the square root function, because we gave them a negative input. Anything below or after will be ignored because an error has been caught. All right. but the call logic is here in the try. So we assume everything works, but we catch any error during the call process if there anything goes wrong. So let's try to run that, see how it works. Okay, so this is our updated exception one. Exception one. Enter number. Let's give it a -1 again. So you can see this is what is given to us. Error input negative. Right. Any questions so far? We got a good question from the chat. Isn't error undefined, or is it part of the catch function? Okay, this is a very good question. So the question was, what is this one? What is this ERR? Okay, so this is an error object that we catch from here. So if there's any error object we catch, and this becomes the error object, and it can be anything. So I just say ERR here, but you can change it to EROR, but it needs to be consistent. And what is in this error, or ERR or EROR, is an error object. And it has two properties. The first one is the error.message, the message property. Another is the error.name. So let's have a look. It has two properties in this error object, error.message and error.name. And let's have a look what's in there. Give it a -1. And the error message is error input negative, where we define here. So we define the error message here. Error input is negative. And the error's name is error, like we defined here. Okay. Yeah. So if you have more, so if you are throwing more errors, anyway, we'll just catch the first error. But according to the error message and the error name, you can know what is the error. So this is very similar to the error message that's thrown by JavaScript or Node.js. For example, we just make a very random error message. So we say X is number of one tab, which doesn't exist, right? So when we run this function, okay, so this is the error message that's thrown by Node.js. Node.js and JavaScript. And the name of this error is TS error, like TypeScript error, right? So this is the error's name, and the error message is unable to compile TypeScript exception 1 here and there. And what did you mean by number? Cannot find name number 1, right? So this is TypeScript defined or JavaScript defined error message, but here we are defining our own error by throwing new error. It works very similar to JavaScript error message. It's just we are defining our own error here, right? And error message is similar to the TypeScript's error message. So it has a name, it has an error message, and this is what we define here. So this is our error name, this is our error message, and they are stored in this error object, this ERR object. Okay. Yeah, I hope this answers your question. Any other questions so far? All good? Yeah, cool. So this is the convention of dealing with errors in JavaScript, and it's called exceptions. Oops, sorry. Let's go back to our slide. Yeah, so what we can do further is, so beyond this one, we can actually use a for loop, a while loop here. So we gotta have a global variable called success. So if not success, we keep asking the user for a valid user input until the user give a valid user input, right? So we can try this and see how it works. Exception 3, and for example, I give it -1, and so like error when inputting and error message, what is it? And then it asks you to enter a number again. I just keep keep giving it a negative number, and it will keep asking me for a value using until I give it a 9, and then the result, like the square root of 9, is shown here. It's just building on top what we have, but the core is the try and catch. So try and catch is the syntax of using exceptions in JavaScript. Yep. It's the same. Yeah, so the key points is here, exceptions carry data, the error object, carry the error's name and error's message. And when exceptions are thrown, normal code execution stops. So we also mentioned that. So the console log A, B, C, D won't happen. Like, let's go back to the simpler. So if we have something like, for example, console.log and A and console.log B, so this won't happen if an error is caught here. So the program is stopped where we catch an error. Okay. We got a question from online. What is parseInt? Yeah, another student answered already in the chat, like make a string to an integer. Yeah, that's true. So when we get an input using prompt function, the input we get is a string. But we want to use a number data type here. So we use the parseInt to make this input a number data type rather than a string. So this is why we had this parseInt. Well, after we read this input data using prompt function. Yeah. Cool. Yeah. Let me see if any other question. Yeah, another question is, what if there are multiple errors? So what if we had, like, for example, here we had a square root parseInt input, and then we had another one, like -1, like even more, even worse, like -1, and then we want to get a square root of -2. So what if there are 2 errors that needs to be cached? What will happen? What do you think? Yeah.
We'll cache the first one first, and then you have to fix the first one, and we'll cache the second one.
Yeah, so we mentioned, that's correct. So we mentioned that whenever an error is catched, the program will be terminated, right? So it won't go to the next potential error, right? So it will stop at the first error. So the second one won't be cached. The program just terminates there. Any other question? Yeah. Okay, so what if there's no error? Will anything in this catch be executed? No. So if everything works well in our core logic, in this try bracket, nothing in this catch will be executed. It will be ignored if there's no error catched. Okay, so the catch error here, so this bracket handles the errors. And here is the core logic. Yeah. Okay. Yeah, so we can also using just test with exceptions. So we have learned to use just test to deal with when an expected output of a function is different from what we actually got from that function, right? So, but what if we want to test the error being thrown? How can we do that? Can we test the error that it's thrown? We want to make sure that we are throwing the correct error, right? So how can we do that? Right, so this is how we test with valid cases, like when the user input is 2, how can, the user input is 4, like square root of 4 should be 2, right? The square root of 2 should be this, like close to this. But if what happens when a user input is negative? We can do similar things, and we use to throw or to throw error. To throw and to throw error, they are the same matches. They are exactly the same matches. They are just aliases of each other. And one thing that needs to pay attention to is that we want to, what is required here is not so in this one, for example, in the normal cases, we want to compare the square root of 4 and 2, right? But when we want to test the error message, we want to compare a function with the error message, because there's no valid output of that function. So we cannot say like square root minus 4 to throw something, right? It's not valid. It cannot get square root minus 4. So what to do here is this function, when the user input is minus 2, it should throw an error, and the error message is error input negative. Right, so this is something that we need to pay attention to. It's different from what we learned before. Like it should be this function when user input is minus 2 to throw an error message. Yeah, make sense? Yeah, cool. So this is how we can use jest testing to test our exceptions. Yeah. So this lecture, what we covered is when we have a JS file, like a standalone JS file, and we throw some errors. But when we move on to iteration 3, we'll be testing across HTTP servers, and the testing will be different. But we'll cover that in a future week, so no worries at all. Yeah, question? Yeah, so the question was, what's the difference between dot to throw and dot to throw error? They are exactly the same. They are just, to throw error is the aliases of to throw. Yeah. Some programmers prefer to use to throw error because they think it makes more semantic sense, but they are the same. Okay, that's all for this lecture. Great. Let's have a break and come back at 12:06. Hey, hello. Okay. Ooh. Welcome back. So this lecture will talk about maintainability, so how we can design software product that is maintainable. So this lecture is, sorry, our online students are asking us to be quiet so that they can hear clearly online. Okay. So this lecture is not directly relevant with any lab or any project iterations, but it's more relevant to you for learning software fundamental, because this is a core concept in software engineering. So when we mentioned in the first week, when we introduced the software development lifecycle, maintenance is one of the core steps in a software development lifecycle. So we have like design, development, testing, and then we have maintain. So imagine that, okay, so what if you are building a large software project, right? And in the middle of your development process, someone dropped your group and a new member joined your group. Do you think it would be better that if this new member can quickly catch up with your progress and contribute to your project? Or do you think it's okay, the code the code we wrote is functioning, but this new member really struggled to understand what we wrote and really struggled to contribute to the project? That would be really bad, right? So we want to write code that when new people come, they can easily catch up with the project. And also, we have a lot of students like finishing 1531, they start to write their own hobby project, and they open source the project on like GitHub or Bitbasket or GitLab, right? So when you have an open source project, what you want is this project can last for longer, right? You also want other people to contribute to your project. So you need to make sure that your code, your project is easy to maintain so that other people can contribute to your project. Right? So it can make it can be more impactful, right? But in other scenarios, like why do we need to care about maintain? Like other than new people joining or open source program want to have more contributors, but what if it's just a Netflix? Like what if for Netflix software project, for YouTube software project, and for this kind of Facebook projects? So in reality, the software evolves all the time. It changes all the time. Maybe you want to have a new feature, right? For YouTube, you want to have a new feature that you can create a community, like people comment on each other's videos or whatever. So you want to have these kind of new features. Or you may want to improve the performance, right? The quality on YouTube becomes better, right? So we are always making changes to our software projects. So no matter whether we have new people join, people left, so the software project is always changing. But we do not want this kind of change to break your product, to break your software project. So well-designed software is maintainable. So maintainable software resists the tendency to break as the software changes or grows. So this topic is very critical. Shh. Thanks, everyone. Yeah, so this topic is getting more and more critical with the rapidly iterative nature of our software. So Netflix, do you know how often Netflix update their software? Many times per day. They are always updating their software. right, to make sure they meet with the customer, the user's need, and make better performance. Right, so we need to make our software maintainable. Okay, and maintenance also not only cares about change in people, change in requirement, change in performance, but also is relevant to bugs. So there's no bug-free software, especially for large ones. So we are always fixing bugs. So writing maintainable software makes sure that when we fix bugs, it won't introduce more bugs. All right. And by writing, how can we get maintainable software? There are a couple of ways. The first one is writing tests. So writing tests make sure that when you make changes to your projects, if there anything goes wrong, you will always get notified, like where this is something went wrong here, right? When you write just testing. So writing good tests is important to have a maintainable software. Another way is to have good system design. So this is more higher level, like system design. So this is this model, that is that model, and how the different models work together. And we'll cover this in a future lecture. But in this lecture, we'll focus more on the code design. So how can we write code that is maintainable? Okay, so both in a high level and in a low level of details. So code design is something happens in between of writing tests and writing our code. So it's when you know what you are going to write, but you need to consider more about how you write this piece of code. And with our project or with our course, we may feel like the due is always pretty soon, like you have the urgent need to finish every function. This is also true in reality, like in industry. We want to finish a feature as soon as possible or fix a bug as soon as possible. So sometimes we may ignore writing good, well-designed code. So this is the tendency, but we need to make the effort. Like first we need to know what kind of code is maintainable, right? And then we need to try to write maintainable code. At the beginning, it may be hard, but when you get a good habit, you do not need to. Well, you still need to spend some effort in that, but it won't be that hard and spend that much time or energy. But it pays off in the future. Like when you make change to your project, right? It pays off in the future. So when we want to write maintainable code, there are 6 design questions that we want to ask yourself, not ask me or not me ask you. It's just ask yourself when you write maintainable code. And we'll go through these 6 one by one, these 6 questions. The first one is there one source of truth for this? So this happens when you have the same logic here and there in your code, and you want to change this logic. But if you have more than one place that has this logic, you need to change the logic everywhere, like having this logic. Well, if you forget to change one of them, or if you change the logic differently in different places, it will cause issue. So the way is to abstract that, maybe write a function or wrap these 2 functions together or whatever. But you need to have only one source of truth for a case. So let's have a look at this one. So this is an example. Right. So this is the example. So have you used argv before? Have you used argv in any lab or no? No. Okay, so argv is similar to when we use prompt func, like read the user's input. And when we use argv, we can also get user input, but in a different way. So let's have a look at this example. Let me go to the correct folder. Okay, I'll just run this function first and explain to you how it works. Run ts node, and this is called dry dirty. Okay, so this is normally when we, this is how we normally call a TS script. But here we have something more. Like after that, we can have another element in this command. Like this is the user input. You can have 2, 3, 4. For example, what if we have 3 here? It reads this 3, okay, and use this user input in your script. Okay, so we have like, in this example, we used npm run tsno dry dirty 3. So this 3 is the argv2. So this is how we get user input from terminal. So this is, so after npm run, this is, this is 0, this is 1, and this is 2. So this is argv0, argv1, and argv2. And this is the length of the user input from this terminal, this command line. And the length of this is calculated using argv.length. And for this particular script, it requires the length to be 3, otherwise it will just exit this program. So it comes from after npm run. So npm run is the standard, right? And then your script here is the tsno dry dirty 3. And this number is the pass in argv2. Like this is 0, 1, and 2. So number here is 3. So when number is 3, it runs this part. Okay, but it can also be 2. So, for example, 1, it is 2. This is what is called here. So it runs this if logic here. All good? Yeah, so this is another way of reading user input from the terminal, from command line. Okay, so now let's have another look at this example. So if the user input is 2, it do this. If there is 3, do this. Otherwise, exit. Okay, so this is the logic. So is there any logic or truth that is in more than one places? So how can we make this script better, make this program, this code better, design better? If you don't know yet, so this my support is the same with like times 3. It would not times 3. So they are the same, but just in different ways to write the code. Yeah. Sorry?
You could take the for loop in a different function.
Okay, so we can extract this for loop here and here. Is that what you mean? Yeah. Yes, that's right. So we are kind of having the same logic here and there, and the difference is that we are using different ways to get the power, like max power here, but they are actually doing the same thing. And in this console log, this 2 or 3 is also determined by here. So how can we make it better? Yeah.
You can either use math.pow or just an asterisk, like have a consistent way of raising something.
So either use this one or this one so that it's consistent? Yeah, okay. So what about we use this one? Because they are the same anyway. What else we can do? Oh, I need to change it to 3 here. What else we can do? Yeah.
We don't have to have 2 separate for loops.
We don't need to have 2 separate for loops. How can we do that? What about I change this one to number, this to number, this to number. Oh, this needs to be a dollar number. Oh, sorry. dollar number. Is that right? And same here. And then if or, so what we can do is if number equals to 2 or 3, we just run this for loop. Otherwise, we exit, process.exit, right? So if we want to change, for example, rather than power plus 1, we change the one place, but we forgot to change here, it will cause issue, right? So, yeah, it's pretty straightforward. Yeah, anything else? Anything else we can make this better? Like we are... anything else we can do other than having the for loop at only one instance? Yeah. I'm looking at online. Any source from online students? Well, waiting for online students to get back to me. Else, what I'm going to do is to delete this part. Yeah. Okay. Any source? No. It's my online students. Any source from here? Anything we can make? Anything more we can do? No? Yeah, so this is from previous term. So a student mentioned that we saw process exit 1 here and here. So can we make a function called exit 1 and then maybe only have something called exit here? So we need to define this exit function, and what's in this exit function is process exit 1 and here. So that is consistent like what exit does. So this is suggestion by a previous student. But it's okay, like we'll come back to this. I'm not too sure whether it's good or not, but we'll come back to that one. But this example is mainly to show you that it's better to have the truth, like one source of truth in your script. So that when you make changes, again, like when you make changes, it's more robust. Another question that you may want to ask is your code as simple as possible? Right? There are a lot of different ways to solve problems, but we want to get the simplest way to solve the problem. So the less lines that you have in your code, the less lines that you need to maintain for your script. For example, if you have 1,000 lines, you need to maintain those 1,000 lines. But if you can do the same thing in 10 lines, you only need to maintain those 10 lines. Right? So the less is better. Right? So write as simple as possible. So every line of code you wrote, you want it to be bug-free. So this is what we call like KISS principle. So you may have heard this KISS principle somewhere before, right? So this is not only for JavaScript, or it's not only for 1531. So this approach is called keep it simple, stupid. So this is a common principle in writing good designed or well-maintained code. So clear code is more important than clever code. Okay. Let's have a look at this example. So the example asks us to write a function to generate a random string with up to 50 characters that consists of lowercase and uppercase characters. How are you going to solve this problem? Checking online. Yeah, you could make the process exit in 1 if similar you have to add a persistent. Yeah. So how can we do that? Okay, so first, like we can write everything from scratch, right? So I can maybe create a string which is like have 50 characters, and add 1 and then 1 and then so in a loop with 50 iterations, right? So this is one way, but there may be other ways. Maybe I can check, see if there's any library from npm, right? Maybe we can just build on top of other people's code and just use one function to just call their function for once. Random string, maybe. Random string generator, random line string. So you can see that there are a lot of examples, a lot of libraries that can do this. Maybe you can choose one. Maybe this is a good one. Like it has a lot of downloads weekly. Potentially it's a good one. And then we install this random string, and then random string generate, we just generate a random string. Random string generate 7, it will be create a string with the length of 7, has 7 characters. So in our case, we can just say random string dot generate 50. But there may be some number in that. So maybe we want to have only characters like letters. So we can have random string generate length is 50, char size is alphabetic. That's it, right? So you can have it just super simple. You do not need to write everything from scratch. And this tends to be a very robust library because it has a lot of downloads. It's quite reliable one. But there may be other libraries that you can try and use. Yeah, but do not use like overcomplicated ones. That's it. So we solved this first example. Write a function that prints what day of the week it is today. What day of the week it is today. I think there's a JavaScript function, right, that can print out the day of the week. I can't remember exactly, but I can always check, right? JavaScript day of a week. JavaScript, yes, getDay method. So there's a method in JavaScript that we can use directly to get the day of the week. Right, so these are some examples, like we build on top of other people's code so that we have less lines in our code to maintain. Right, okay. Write a program that takes in command line arguments. Okay, we have already saw 2 examples for this. Like one is use prop function, another one is use the argv. Right, we can get command line arguments. Right, so we do not need to write our own functions. We just use the libraries already exist for JavaScript. But this is not always the case. There are still many cases that we need to write our own codes. It's just giving you some reminders, like if there's some code like we can use directly, we do not need to write our own. But in many, many other cases, we still need to write our own codes. Okay. The other question is this over-designed or under-designed? Okay, let's come back to this example, the mass power one. So we mentioned that maybe we can just define a function like abstract this process exit 1 in a function called exit. So this is actually an example of over-designed code if we extract that like this. Because, so you may not know yet, but as you like write more code like in software engineering, you may know that process.exit1 is something that programmers know what is it. But if you have something like just exit, they don't know what that is, and they need to check and find this function, find where you define this exit function and see what is in that. So this is over design. But if you have just a process exit 1 here, like everyone knows what that is. Alright, so that is actually over design. But under design is the original example we had, like we had a for loop in 2 different places. So that is under design, like you need to design it better. But abstract the script too much, it might become, over-designed. So sometimes repeating ourselves twice, but only twice, is okay sometimes. Unconditional conforming to a principle is a bad idea. So you do not need to conforming to any of those principles, but sometimes add complexity back in. So this is hard to balance actually, like whether we are over-design or under-design. So this is hard to balance at the beginning. So as a beginner, like software engineering beginner, most of us will write like under-design code, like can be designed better. But gradually, we may find us like starting to over-design stuff. And then we can get a good balance. Like when we write more and more code, we can starting to get a good balance of well-designed code. Okay, so another two questions we may want to ask is, are related modules kept close together, or are unrelated modules kept far away? So this is when you want to change a feature, for example, register. You want to have all functions about register close to each other. So when you make changes, you know, well, there's another function that I need to change about like register. But if they are too far away, maybe you forgot to change that, or maybe you can't find where is it. Right? But if you keep relevant things together, it kind of work as a reminder. Well, like when you change something, there's something else that you need to change, and you also know what has been changed in the relevant functions. And actually, we'll talk more about this in the future week as well. So we won't make it too complex today. This is a very, very common mistake that I made this mistake a lot. Am I speculating about how necessary this is? So to make it short, like we want to start necessary things. So when you write a function, write a piece of code, or write for a feature, ask yourself, is this essential? Is this necessary or not? So we have a lot of perfectionism. Like we want to do things perfectly. We want to write good code. We want to have a good project. We want to have a good software. So sometimes we may think, well, I want to add this one. I want to add this function so this can be better. Or I want to have this feature. I think have this feature is great for my product. But before you do that, ask yourself, is this essential? Right, so we do not want to add overcomplicated things, make your software overcomplicated. That can introduce maintenance issue. Right, so start with essential things. Is this necessary? Right, ask yourself, is this function necessary? Right. This is also true when you write the test cases. Right, so there may be some test cases isn't necessary, right? And when you write that, you need to also maintain that as well. And this is a principle called you aren't gonna need it. So this is like KISS principle. So this is a key principle of software design, like you aren't gonna need it. So you can see that a lot of programmers, software engineers make this mistake, like they overcomplex things. And the seventh question to ask yourself, does this follow standard convention? So you won't want to write your web application backend in C programming language. Right? So this is not a convention in writing web backend. Right? So if you write C in backend, you are going to introduce trouble for yourself. There will be less resources for you. Like how can I write a project backend in C? Right? There's not much resources for you, and people don't do that. Right, and this can also be about how the style, like how you write the style, like uppercase constant or how we use the library choices. Like we use Express Server because Express Server is popular in industry. Like everyone is using Express Server for their backend in industry. So this is why we are using it, right? Then there will be a lot of resources, and people are. It also make it easy for other people to understand your backend development, right? Because they are familiar with Express, and there are a lot of resources. Any questions so far? Yeah, I found this lecture every term is very hard to deliver. Maybe because it's kind of more boring comparing with like more practical lectures, because a lot of conceptual things like me talking, not much demonstration. But these are some questions that at least we want you to know. Like when you write a code, you know those are the key principles. Like you want to remind yourself to follow. For example, keys. For example, what was that? Keys. This is called Yageti, which is like you aren't going to get it. So these are very common principles for code design. Okay, where are we? Yeah, this is. Yeah. Okay. So another terminology that you may have seen or will see is called refactoring. So refactoring is a common process in software engineering that after you already written your code, you may go back to your code and refactoring it, like means restructuring existing code without changing its external behavior. Like the function still does this behavior, but you make some changes of how the code looks like. This is called refactoring. And refactoring is very, very common. It is very, very common. But refactoring is strongly discouraged if you do not have a good test suite. You may introduce more bugs to your software programs. Okay, I don't want to make this this lecture too long because I know it is a relatively boring lecture. But it's important, right? It's important. It's not as interesting as when we talk about coding. All right, so this is everything about today. So this week, the only thing left for the lecture is iteration 2. So we will focus on iteration 2 on the Wednesday's lecture. Okay, have a read of your spec, have a meeting with your team member, and come to the Wednesday lecture, ask questions, and and we'll explain more about HTTP server. So if you are still confused about HTTP server, we will explain more about it in the iteration 2 lecture. Thank you, everyone. Thank you.